Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. CS 3352 Foundations of Data Science, Unit 4 Python Libraries for Data Wrangling. I'm going to explain the topics hierarchical indexing on large data sets and aggregation and grouping in pandas. First topic, hierarchical indexing. It is a method of creating structured group relationships in data. Hierarchical indexing or multi-indices is one of the functions in Pandas, a software library for the Python programming languages. Pandas derives its name from the term panel data, a statistical term for four-dimensional data models that show change over time. Hierarchical indexing example. We can create a multi-index from the tuples as follows. We have to write the statement pd dot multi-index from tuples of index. If we print index, it shows the output like this. See, here is the output of the tuples. The state names are, notice that the multi-index contains multiple levels of indexing. In this case, the state names and the years as well as multiple labels for each data point which encode these levels. If we re-index our series with the multi-index, we see the hierarchical representation of the data as follows. For this, we have to write pop is equal to pop dot re-index of index. We are changing this multi-index to the hierarchical representation of the data. If we print it, we will get the output like this. Here, the first two columns of the series representation show the multiple index values, while the third column shows the data. Notice that the some entries are missing in the first column in this multi-index representation. Any blank entry indicates the same value as the line above it. Now, to access all data for which the second index is 2010, we can simply use the pandas slicing notation like this, pop colon comma 2010. So the sliced data will print the output like this. We could easily have stored the same data using a simple data frame with index and column labels. The unstack of method will quickly convert a multiply indexed series into a conventionally indexed data frame. See here, year is one column. Year is taken as one and second column, and states are the values for the states for the year will be represented in a row format. This is called as a data frame with index and column labels. As with a one-dimensional numpy array for a pandas series, the aggregates return a single value. We have seen the aggregation in numpy array. The same thing we are going to see in this pandas also. So to do this, we are writing a series ser is equal to pd dot series of rng rand of 5. So if we print ser, we will get the output like this with its index values. If we use the aggregate function sum of ser dot sum of, we will get the output like this. If we can use the mean of a function, it is also one type of aggregate function ser dot mean of, we will get the output like this. For a data frame, by default the aggregates return results within each column. So we have chosen values for 8th column and bth column. Now the output will be like this. For 8th column, the output will be like this. df dot mean of. So it aggregates the values by column wise. So 8th column's mean is here and bth column mean is here. By specifying the access argument, you can instead aggregate within each row. So if we want to specify the access columns, we have to write within parenthesis mean of parenthesis access equal to columns. So it will aggregate within each row and produces the result like this with its index values. Thank you.